Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic name is B trees and this topic you will be finding in the last topic of 4th unit. Now let's get started. So this video will be going to talk about M-way search tree. Prior to this video we already covered about what is disk structure and what is indexing. So we already covered these two things in the previous video, and this video is about M-way search tree. Now, so what is M-way search tree? Let us recall about binary search tree, which is useful for searching purpose. And for searching any key value, we start from the root. If the key value what I am searching, if this key value is less than the root element or smaller, then we'll go to the left hand side. If the key element is greater than the root element, then searching operation will be in the right hand side. Right? Now, that means we'll take some example. 10, 8, 20, some 3, 9, 15, 30. Now look at this. So what binary search tree is? Binary search is the best example to search one key element where the nodes are single entity. Now my key element is what? Let's suppose that key element is 15. I wanted to search this 15 whether it is available in the key or not, in the tree or not. Now what is that? If my key element is equal to root element, then we will be displaying that the element is found in the tree. If it is not, else if key element is less than from the root element, then probably you are searching operation at left subtree. If it is greater than, then it will be at right subtree. Now as far as 15 is considered, first condition will get failed, that is key element is not matches with the root element, and it is supposed it is greater than from root element. So searching operation will be on right hand side. In right hand side you have here 20. So 20 is again act as a root element. 20 less than equal to 15. So it is not. Less than 15. Yes, the condition true and your element is 15 over here. So this is what binary search tree, what we already know. Now let's understand how binary search tree works, the main parameters of this binary search tree. Binary search tree, if you keen observe that we can have per node just one key. That means when you see binary search tree, you already just now we were seeing, right? 3 9. So how many keys are available in the root position? Only one key. How many keys are there in this node? 1. How many keys are there in this node? 1. So in binary search tree we can have per node one key. And how many children each node can have? At most 2 children. At most 2 children. That means 0, 1, 2. At most 2 children. Now can we have a tree with more than 2 children? And can we have a tree more than one key? If it is, then that is called as M-way search tree. So point is very clear. M-way search tree is also binary tree. But the difference is what? You will be having, it is just like a binary tree, but the major differences in between these two are, in binary search tree, you will be seeing at most 2 children. In M-way search tree, you will be seeing 2 children, greater 2 children, or we will have more than 2 children. And the second difference is, in binary search tree, you have only one key per one node. Only one key per one node. Whereas in M-way search tree, you can see many nodes in one, many keys in one node. That means 10, 20 can be existed in M-way search tree. In binary search tree, 10 will be existed in the root place and 20 will be existed in the right subtree. That is the difference. Now, let's see with an example how M-way search tree is considered. Now, we'll take some example. That the example is what? I wanted to arrange 10, 15, 20, 30, 35, 50, 60, 90. Using of these elements, I wanted to draw by M-way search tree. Now, how I can draw M-way search tree is 20, 50 are in the root place. Now, if I wanted to search the next element where to be inserted, I have to check with this root elements. Let's suppose that I wanted to insert 10. So where I have to insert, I have to check with this 20. So it seems to be less than of this 20. That means you have to come to the left hand side. Now 10 will be here, 15 will be here. Now these two elements are found to be lesser than this 20. Now, so whatever you found greater than 50, you keep right hand side of this 50. So what are their right hand side? 60 and 90. Now what elements you found in between of this range? Now place over here. What elements you have? 30 and 35. If you see all these elements, now let's see that K1, K2, K3. That means key 1. Key 1 is what? 10, 15. These are what? Two keys which are presented in node 2. Let us suppose root is node 1. Node 1 is having two keys over here. Whereas in the binary search tree, each node is having only one key. In M-way search tree, nodes are existed with two keys. More two keys also will be going to see in the next example. Now, so this is node 2 with two keys. Node 3 with two keys. Node 4 with two keys. If you see all these keys, these are arranged in an order, sorting fashion. That means K1 less than K2 less than K3 less than K4 up to dash dash Kn. Now, how searching operation will be possible in M-way search tree is, if I wanted to search any element, that I will be searching with this root element. Let's suppose that I wanted to search 30. When I wanted to search this 30, the way how we did in the binary search tree, the same way we'll be going to approach in M-way search tree. Now 30 is your key element. We will be going to we will be going to check this 30 whether it is equal to root or not. Now root is having two elements. Now 30 will be get compared with this 20 element. If it is matches, then element is found, we will be printing. If it is not matches, then we will be checking whether it is lesser or it is greater. If it is lesser, we will come this side. If it is greater, then what we will be doing is, we will be going for this node. And we will be checking whether it is lesser or greater. And if it is greater, we will be going to check. If it is in between, we will come to this line. So 30 is not lesser, it is greater. And we will be come to this line where 30 is available. So this is the way how we will be performing searching operation in M-way search tree. Now let's understand what is M over here. Now that is, node is having 3 children. So it is called as three-way searching. M sounds that the number of children per a node. So it is one node. Node 1 is having how many children? 3 children. So it is called as three-way search tree. Now, so you will be having three-way search tree, whereas let's see that it is of M, then you will be having M minus 1 keys in each node. When you are using M-way search tree, the keys are presented in each node, which is M minus 1. And that's what this is three-way search tree, and the available keys in each node are M3 minus 1, which is 2. We'll take the other example. This example also I am giving for M-way search tree. Now the other example is, I am taking the example of 4-way search tree. That means how many children each node will have? 4 children. How many keys? The possible keys with each node? 3 keys. Okay, now this is the way you have to understand. Now we'll see that the node creation, one single node creation, how it will be. So I told you that node will be having how many keys? 3 keys. Now let's draw that 3 keys: K1, K2, K3. Now, so these, the address, these are what? Child pointer. Child pointer 1, child pointer 2, child pointer 3 and child pointer 4. So you will be having 4 children, I told you, right? For each node you will be having 4 children. So this is what? Child pointer 1, child pointer 2, child pointer 3, child pointer 4. Then what do you mean by this? This is what? Record pointer. Now M-way searching will be having a record pointer for each of the key. So this is what we were discussed in the disk structure, and this is the exact relation of using data structure with the database. Now whatever data I am having here, I am just maintaining the record pointer where I wanted to access the indexing with what the data, what the table I have stored in the dictionary or else in the disk. Now this is what record pointer. So record pointer, why record pointers? Or RP is a record pointer to connect to the database. Now let us check how we can do index with M-way search tree. Now we'll take some more example and we'll see. So that means we will be going to have a node something like this: K1, K2, K3. So this is what. So here each this I'll point out: child pointer, child pointer, child pointer, child pointer. Each, if it is a 4-way search tree, node will have 4 children. 4 children. These are what? 4 children. Now, so let us talk about some properties of M-way search tree. So basically M-way search tree is what? M will indicate you how many children the tree is going to have, and M-1 will represent you keys. And the next point is the leaf nodes of this tree will be in the same level. Okay. Now, so we'll take the other example to identify the drawback of M-way search tree. The drawback of M-way search tree is what? If I wanted to insert any node, let's see, I'm taking some example that I'll be giving 10-way search tree. That means, what do you mean by 10-way search tree? That it will have 10 children. 10 children, and the keys in one node is 10 minus 1, which is 9. So if I wanted to form a tree or construct a M-way search tree with the following nodes of 10, 20, 30. Node capacity is what? It can have 9 nodes. That means 10, 20, 30 all should be in one node. But as far as there is no rule, no guidelines to have an creation process of a node, I can do like this also: 10, 20, 30. Even this will not give any wrong as far as M-way search tree is considered. So this is what a great drawback, because to search the 30 element I have to go through with all these comparisons, right? So this is what a drawback. Now what we'll do is we'll keep some rules to M-way search tree. We'll apply some rules. M-way search tree plus some rules is called as B trees. Yes, M-way search tree with rules is called as